All right. Good afternoon, everyone. Thank you for attending today's webinar on residential changes in the part one. The webinar will be recorded and the recording is sent out to all attendees in a follow-up email with a link to Google Drive. If there are any issues with audio, please write me in the chat. My name is Erica DeLello, and I'm a project manager for NORESCO. This series is sponsored by the Colorado Energy Office with training materials created by Robbie here from BuildTank. As you can see, we've been working with the Colorado Energy Office to put on trainings just like this one. There's a list of trainings here, and we've added a bunch of new ones. So I did send out a pretty large mass email yesterday. If you see any other trainings that catch your eye, feel free to register through that link. And then in addition to these Wednesday webinar series, we also do tailored group trainings or technical assistance. And that can also, you can also reach out to me about that. I think there's a couple links in that email as well for how to sign up for those too. But then in addition to all of these trainings and technical assistance, we're also working on building our code adoption toolkit. And that reviews cost implications, changing code cycles, you know, what the benefits are, and a lot of other compliance resources, including a code adoption toolkit, or including a troubleshooting guide that will cover iCode conflicts, alignments, clarifications, and passive compliance. Both of those resources can be accessed through the Colorado Energy Office's website. And then lastly, we do want to encourage questions throughout today's presentation. So please use the Q&A function, and I'll let Robbie know at the end. The chat window can also be used among participants. And then you can also raise your hand to ask a question at the end, and then I can unmute you and you can ask Robbie directly. There will be a survey window that pops up following the webinar. If you could just take a minute to fill that out, that'll help us to continue to improve on these. So today's presenter is Robbie Schwartz, and he founded BuildTank to be a practical building think tank to do research, education, and work with builders to ensure that their homes not only comply with codes and programs, but also perform. At BuildTank, they strive to use what they learn from work in the field to affect meaningful change in the construction industry. So Robbie's an expert in the residential energy side of things. So if you have any questions, don't hesitate to write a question in anonymously or as yourself. So with that, I'll let Robbie take it from here.
Great, thank you, Erica. We're gonna do a little switcheroo here on screens. I'll just take a second. Okay, screens are shared. Thanks everyone for taking part today. Really appreciate that. I'm going to turn off my video so that you can concentrate on the slides, and then when we get back at the end and do some questions and answers, we'll come back live there on video. So today we're going to be talking about the 2021 IACC. We'll be talking about significant changes. This is part of a series of presentations that will be coming up. Part 2 here will be a deep dive into the 2021 IACC compliance pathways. Then later in March, we'll be talking about testing and diagnostics on the residential side, whole house controlled mechanical ventilation and indoor air quality, again on the residential side, and residential inspections, real world examples of what to look for on the residential side as well. And Erica showed you some other presentations that will be taking place in the next few months that also include some commercial training as well, but these are specific to the residential side. Today, we'll be talking about this notion of the 2021 and it kind of being this apocalyptic moment here. Give you a little bit of the background story for that and what the reality is. We'll be talking about the changes specifically that impact efficiency and changes in the 2021 that don't impact efficiency, but impact compliance and verification. And then ultimately what it all means. So the first time we had this kind of a apocalyptic moment was with the 2021 IECC. I'm sorry, the 2012 IECC. That's when air leakage testing became a mandatory part of the code. And people had not begun to adopt this code yet. And when people realized that they had to start doing testing and they didn't really understand how they were going to meet the actual requirements of 3 and 5 air changes, depending on the climate zone that you want. So people really felt that it was going to be difficult, probably more difficult than it was. And therefore, they had this kind of doomsday event perspective on it. And that's kind of carried over with the 2021 IECC, because there's this expectation that this code will have a Department of Energy determination that it will be about 10% more efficient than the 2018 IECC. So that kind of gives us this framework of how are these determinations made and what do they ultimately mean. So what we see is that the 2006 IECC is really this reference point. And from the 2006 to the 2009 IECC, there was a determination that about a 15% increase in efficiency was achieved in that code cycle. This was primarily achieved by changing or increasing R value and U value requirements in the building envelope. From the 2009 to the 2012, as I said before, there was about a 15% increase in efficiency that was largely gotten on the back of air tightness. So we moved from no requirement for air tightness testing and this kind of vague requirement of about 7 air changes per hour to specifically requiring testing and a requirement of 3 or 5 air changes per hour, depending on your climate zone. Because the 2015 cycle happened and the majority of the country had not yet adopted the 2012 IECC, there was really only an increase in efficiency of 1 to 2% in that code cycle, because I think that there was this recognition that we needed some time for the municipalities and builders and whatnot to catch up to where the codes were gotten. And that really almost took 2 cycles there. So we see in the 2018 cycle that there was also only an increase in efficiency gained by that and by about 1 to 2%. And now we believe that there's going to be about a 10% gain between the 2018 and the 2021 IECC. Now that determination hasn't been made yet by the Department of Energy. And the other thing that we need to realize is that this is on paper, this increase in efficiency. How things actually get adopted and enforced in the field is the true determination of if these efficiencies that are demonstrated on paper actually happened out in the field. So that's kind of the background. I don't think that we're going to see that it's that that apocalyptic feel, I guess, I don't think is going to be as big a feeling once we start diving in here and understanding what the changes really are in the 2021 IECC. So let's begin to look at that. We're going to look at it from 2 perspectives here. We're going to look at it from changes that impact efficiency and changes that don't impact efficiency, but impact how you actually implement the code or execute it and verify it out in the field. So beginning with the changes that impact efficiency, those changes primarily happen in the pathways that are used to demonstrate compliance with the IECC. So we have these different pathways. A new pathway was added for tropical climate zones, which isn't going to impact the majority of the landmass of the United States. But there was also these additional energy efficiency requirements that were added to all of these pathways. So there's some additional things that need to happen when you choose a pathway through the code to demonstrate compliance with. Now, the prescriptive pathway, we also need to talk about a little bit, because the prescriptive pathway, within that pathway, there are a number of different choices that you can make that go beyond these additional efficiency requirements. And we'll talk about those in a moment here. Now, these additional efficiencies, this section establishes these efficiency requirements that are applicable to all the compliance approaches, or these pathways that you take through the code. The prescriptive compliance pathway, you choose one of these efficiency packages that are laid out that I'll show you on the next slide. Total building performance compliance. This used to be named the simulated performance compliance pathway. Now it's named total building performance compliance pathway. You also need to choose one of these efficiency packages. However, these efficiency packages can't be modeled to demonstrate additional efficiency for your compliance when you're creating the cost compliance report that demonstrates compliance for that pathway. The cost compliance report, however, your other choice is to actually demonstrate that you're 5% better than the reference design if you're using that pathway. So you do have two choices here of demonstrating compliance. Most likely people will be using the cost compliance 5% better than option, because it's more straightforward and easier. If anybody is using the energy rating index compliance pathway, they are also using this 5% better than option for that pathway through the code, instead of choosing an additional efficiency package. Now, the additional efficiency packages look like this. There are 5 choices that you can make. You can enhance the envelope performance. You can get more efficient HVAC equipment, more efficient water heating equipment, more efficient HVAC delivery, how the ducts are actually run and located in the building, or you can improve air sealing and ventilation requirements in the code. So when we talk about this prescriptive method, I'll go back a slide. The prescriptive, you have to choose one of these efficiency packages. These are one of the choices that you can make. You can choose from one of these 5 things here that are outlined in section 408 of the IACC now here. So it's creates a little bit of confusion, but I think as we get used to it, it will be pretty straightforward how it works here. So section 402, building thermal envelope prescriptive pathways through the code. There are defined in this section 4 choices that you can choose from. You can choose this insulation and fenestration criteria. This is basically looking at the assembly U value table and choosing and creating a home that meets these components. This is kind of a thou shalt built perspective. It's not as easy because you are looking at the total assembly, not just the cavity R value. So not a lot of people use this approach unless they're doing a software or utilizing a software to do that. It's much easier to use the R value alternative, which has 2 components to it. One of them is an R value assembly approach. The second is a cavity R value approach. And this is really what most people think of when they think about the prescriptive pathway through the code, is the R value computation or R value cavity approach. You're just looking at the table. You're saying that the table says you have to put an R20 in your wall cavity and maybe something on the exterior as continuous insulation as well. It's a straightforward approach. And this is what most builders gravitate to, because it's basically tell me what to do and I will do that type of approach. Now, the last approach that is used in this prescriptive section is the total UA alternative approach. This is where you start to use a software. The most recognizable software out there is called ResCheck. That is a free download from the P&L laboratories, I believe. You can get it at energycodes.gov. But there are other softwares like REMRate and Ecotrope that are also used to create an energy rating index that can also do this UA trade-off approach. So you're creating a area weighted U value for your rated design and your rated home, and your rated home has to be better than or equal to the rated design there. If you can demonstrate that, then you've demonstrated compliance with the code. So this has changed a little bit. It's become a little bit more confusing than it was in the past, primarily because there's this assembly R value approach now. And again, not many people will use it, but it is a possibility that you can do that instead of the assembly U value approach there. Anyway, let's move on to the prescriptive R value table. This table has changed pretty dramatically here, but this table is looking at it from a cavity component perspective here. Now, the U value table is also a table that is embedded in this prescriptive section of the code. The U value table is an assembly-based table, and the assembly is equivalent to if you're just using these components in the cavity that are called out in this table here. Because if you were to add in the assembly components like the drywall or the studs and the exterior sheathing and air films and whatnot, you would get approximately the same component. If you did the reciprocal of the R value to get your U value, you would get roughly the same number there. So when you look at this U value table, you'll see that things have changed pretty significantly here in what they're asking for. I'm going to use climate zone 5 here on the Front Range of Colorado. Look at the ceiling R value went from R49 to R60. The wall assembly went from an R20 assembly to an R20 plus 5. That means that plus 5 means the continuous sheathing on the exterior, and so forth and so on. So some things have changed pretty dramatically, but some things haven't, like floor systems. R value hasn't changed that much. Basement walls haven't changed since the last cycle as well. But fenestration U factor has changed a little bit. So you need to look at, if you're using this pathway, this prescriptive pathway, you need to look at these R value changes and make some changes potentially in how you're specifying the home and how you're going to execute these things. So for example, if you're going to use an R60 in your attic, well, you're probably going to need a raised hill truss. If you're going to use the wall assembly at 20 plus 5, you need to figure out how you're going to do that R5 continuous insulation on the exterior. So those are some things that definitely change things pretty dramatically. When we move on from the prescriptive path and look at the total building performance pathway, we need to think about how that compliance works. So in the 2018 and earlier codes, basically you had to do what was called all the mandatory aspects of the code, as well as what was required in section 405 for the total building performance. The first thing to remember is that total building performance is the same as what used to be called the simulated performance path. But now what these mandatory requirements have been gathered up into a single table that starts section R405. This single table here is a combination of all those things that were considered mandatory. Most of these things come from the prescriptive section of the code. Most of these things are dealing with how you actually install something, not the R value or U value, because the R value and U value, those are the things that can get traded off. And we'll talk more about trade-offs and what trade-offs mean in later presentations. But in general, a trade-off is the ability to put a lower R value in a component. So for example, that R60 attic that is now being required in the prescriptive path, If I want to continue to put an R49, then I have to be able to trade off that R value or that performance somewhere else in the building envelope. So if I put in much better windows or more insulation on my slab or basement foundation walls, I might be able to trade off that performance, that lower performance in the attic, for higher performance somewhere else in the building envelope. That's really what the total building performance pathway, section R405, is doing as well, but it does it on a more holistic and building science-based basis because it also takes into account house tightness. So you can trade off house tightness for R value because they're both conserving energy over the life of that house in essence. But remember that these mandatory items are now basically just called requirements. You have to do everything that's listed in this table, and then those things that are listed in the prescriptive section are primarily how you actually install something. An additional thing that was added to this section is this notion of a backstop. A backstop is saying that you can't do anything less than for this particular section, and how it's been implemented in this section, the building performance section. It says that the building thermal envelope shall be greater than or equal to the levels of efficiency and solar heat gain coefficients that are listed out in the tables, the R value and U value table of the 2009 International Energy Conservation Code. So basically, you cannot put in an R value less than that's listed in the 2009 International Energy Conservation Code. So for example, I could not trade off less than an R49 in that attic location. So that means that your ability to trade off is lessened in this from this pathway in order to keep a base level of efficiency that is defined by this backstop. Now, the concept of the backstop was first introduced in the 2015 IECC with the Energy Rating Index pathway, section R406. So you can go back to that code if you're interested to see how the backstop was executed there. But this notion of backstop has been moved forward and now has been applied to this other section, this R405 section here. Lastly, from a reporting perspective, some things have changed in the total building performance section. It's requiring a compliance report for your permit application. So you need to turn it in to get your permit. This is called a projected compliance report. You're projecting that your house will perform in this way, and then you have to prove it with a confirmed report in order to get your certificate of occupancy. So it requires these two things. And then the last thing that was removed from this pathway that not many people used, but sampling was allowed for stacked multifamily units in this pathway in the past codes, but in the 2021 IECC, sampling was removed from the code in its entirety. So if you might have some folks that ask you about sampling and the ability to use sampling, primarily for blower door testing and duct leakage testing, but sampling is something that is now removed in its entirety from the code and is only at the discretion of the authority having jurisdiction, whether they will allow it or not. And then this new trade-off credit was added in the building performance section. It's added in the table that defines how you build the reference home and the rated home when you're doing a computer simulation or an energy model of a home. So it's kind of behind the scenes, but if you have compact hot water distribution design, you can get some additional credit on your home's efficiency. And this additional credit is based off of this ratio of the area of the rectangle that's in red in this example that bounds the sources of the hot water and fixtures versus its potential total service area here. So in this little example here, you get a hot water distribution efficiency factor of 0.05 that you can add to your efficiency, and you can get some additional trade-off credit for that in your computer analysis there. Again, it's defined in the reference home table for section R405, the building performance section, and that's where you would find it. So the software developers will need to take that into account, and potentially if you don't understand how a house is actually complying with the credit, you might have to go, with how it's actually complying with its cost compliance report, because you can't tease out the different things that they're trying to trade off. You might need to look at this additional means of trade-off that is added into this equation here. Okay, the energy rating index compliance alternative. This code is looking at the ERI. Remember that the ERI for code is not the same as the ResNet energy rating index that is defined with this certificate. So you need to look for the correct certificates. The first thing that's happened in this pathway is that the code compliant energy rating index score changed from the 2015 to the 2018 and has gone back to those 2015 requirements in the 2021 IECC. So the same scores that were originally developed in the 2015 IECC, those have been returned back to that level in the 2021 IECC. So in climate zone 5, you have to achieve a 55 or less. But remember that 55 isn't the same as a ResNet HERS energy rating index. It's a different score, and it's actually more difficult to achieve from a code perspective here. On-site renewables included. So this is where the backstop was created in the 2015 IECC. It says where on-site renewable energy is included using the energy rating analysis, the building thermal envelope shall be less than or equal to the levels of efficiency of the 2015 IECC. This is a backstop for the insulation levels so that you can't trade off less than a certain level of insulation in that building thermal envelope there. So this is the table that was created in the 2015 IECC. So if you look at climate zone 5, for example, you can't trade off less than that R20 wall or an R49 attic, for example, here. In 2021 IECC, it says for compliance purposes, any reduction in energy use of the rated design associated with on-site renewables shall not exceed 5% of the total energy use. So if you're doing if you're using on-site renewables, you can't necessarily use those on-site renewables to reduce your energy use to demonstrate compliance with this pathway of the code here. So how do you actually get to that energy rating index of 55? You can only use 5% of on-site renewables to get to that energy rating index of 55. Whereas in the past, they were using a different type of backstop. So that is changed here for section R406. Verification for R406 is also changed in the 2021 IECC. It says that the ERI compliance shall be completed by an approved third party, which basically means that generation of the ERI score is going to be done by an approved third party, usually an energy rater, a ResNet energy rater, for example. But verification of compliance for the mandatory requirements or those things that we talked about before in section 405 that are listed in a table, specific to this section and specific to the section 405, that verification can be done by the authority having jurisdiction or by an approved third party. This was entered into the code because we want to basically ensure that the jurisdiction having authority understands what the third party is doing and what they aren't doing, and they're specifically allocating that level of verification to the third party if they want them to do that or not. Remember that all the overarching code requirements are required for this pathway as well as all the other pathways. And that approved inspection agencies is a defined term in the code, and you can go to this section in the first chapter of the IECC and find out more about approved inspection agencies there. Reporting is also changed for the energy rating pathway of this code. It's looking at also getting a projected compliance report for permitting and a confirmed compliance report for the certificate of occupancy to be issued here. This is what that report looks like, and you can see how different it looks than the energy rating certificate that I showed you before, that the ResNet energy rating score is shown up with. And then the last thing that changed in the energy rating index pathway is the renewable energy certificate. It's just brought up in the code because they want to make sure who ultimately gets this renewable energy certificate, and that the renewable energy certificate, because it is a monetary certificate or could be used as a monetary certificate, they want to make sure that that it's known that the code officials basically are not going to take the certificate, but they want to know who actually owns that certificate in essence here, because it could be used in a, from an economic perspective, it could be used. The tropical climate zone was added, and that's a new section of the IECC, section R407. We're not going to go through it, but this is how the tropical climate zone is defined now. There are some changes to Chapter 5. This is the existing home section. Primarily in the addition sections, it says that it shall require to be brought into full compliance with this code, and that you can use now the simulate performance option and demonstrate that the proposed design will be 110% better than the reference home here. So you can show that the existing home, you basically benchmark the existing home and show that you propose it to be 110% better than that existing home. And then you have to show also at the end of the process that it's going to meet the requirements and actually be that 10% better than here. So this says that you can do this using the simulate performance path, or you can also use it using the total UA trade-off pathway as well here. Oops, I went the wrong direction here. And this is more explanation of that annual cost compliance. That's the total building compliance path in R405. You can use that pathway to demonstrate compliance with an addition that is added to the house. So in essence, this chapter is now using and leveraging this statement that's been in this chapter for quite a while that says that the building with its addition has to be better than the existing building was before. And now you have a means to actually quantify that it is better than by using either area weighted trade-off or the cost compliance report in section 405. In the last kind of thing that potentially increases efficiency is this appendix that was added. This is a zero energy residential building provision to demonstrate how you can get to zero energy. It says compliance with this section requires that the rated design be shown to have a score, an energy rating score that is less than or equal to the values in the table. And that means that because they did not do a ventilation amendment, that these scores are equivalent to the ResNet HERS energy rating index score values here. And what I'm trying to demonstrate here is that they did add this little adjustment that's looking at renewable energy in the equation as well. But in general, you have to get to a new score that's defined by the ResNet scoring system, the energy rating index that is defined by ResNet here. And in climate zone 5, in order to comply using the zero energy compliance metrics, you have to get to a score of 47 before renewable energy is added to the equation here. So you can look at this section, this new section of the code, if you'd like to try to get your municipality to zero energy homes. Okay, so let's move on to those changes that don't impact efficiency, but impact the rater's field inspection or the code official's field inspection out there. So first it begins in the administrative section here. The administrative section here is something that often gets overlooked when the adoption of a new code happens, but it's an important thing to look at. So first of all, we need to think about construction documents versus compliance documents here. Construction documents are those that we used to actually specify how the house is going to be built. Compliance documents are those that we use to demonstrate compliance with the IECC here. Those things include the proposed and confirmed documents that we just discussed, the area weighted U value, the cost compliance report, or the energy ready index rating index report, as well as duct leakage and air leakage reports here. So those have been called out and more specifically, and there's differences there. And the main reason it's been called out is because you don't have to have a registered design professional create the compliance documents, only the construction documents. This section of Chapter 1 is looking at the details that need to be included on the construction documents. Now you have to include the energy compliance pathway on those construction documents so that it's clear at permitting what compliance pathway they're going to use. And you also need to include air sealing details on those construction documents. Air sealing details would be something like this that determines what the how they're going to get that air barrier behind the tub or that air barrier in this drop ceiling location correctly. Something that was added in the 2015 IECC is this depiction of the thermal envelope on the construction document. And that can be done like this, like is explained here, demonstrating the interior and exterior air barrier systems, or it can be done in other ways as well. But that depiction needs to happen on the construction documents. Inspections for footings and framing and plumbing and mechanical and final and re-inspections are defined in the code. From an energy perspective, we need to remember that we're looking at framing, for example, for R values and their correct location and proper installation, and air leakage controls, all those things that are defined in the air barrier and air and insulation installation table. And then, for example, mechanical details that we should be looking at, which could also include R values and system leakage. So how leaky is the ductwork or whole house ventilation systems that we need to be looking at as well. So this has really changed the way that we inspect our houses. In the 2021, we're looking at things that need to be in the house. So we need to look from the perspective of, are those things actually there? like this fan, has it been installed in the bathroom? But we also need to look at how it's been installed and if it's been installed so that it will actually perform. So if the duct from this fan to the outside has been tied into a knot, we know it's not going to actually work. We need to fail it and look at how it's going to get reinstalled so it will actually perform. So is the insulation there, and has it been installed so without compression, gaps and voids? Has it been installed so it's split around the wiring or other obstructions in the cavities so that it will actually work? Is this HVAC system been installed according to the plan so that the air will actually be delivered and returned in the way that it needs to be, so that it's equivalent to the design and matches the thermal envelope that actually has been installed there. Chapter 2, there's some new added definitions to the code, and there have been some revised definitions in the code. So you can go to Chapter 2 and look at those and understand how those are been redefined or new definitions added that will help. You'll see that on the added definition side, a lot of it has to do with renewable energy. As renewable energy starts becoming more and more something that is looked at in the 2021 and codes beyond there. Chapter 3 is the chapter that defines our interior design temperatures so that we can get to that temperature difference between inside and outside, because energy is always moving from higher concentrations to lower concentrations. So this interior design condition is used in our HVAC design and is defined there specifically in Chapter 3. Chapter 3 also deals with building thermal envelope insulation. It talks about the R value mark that needs to be provided for each component of insulation that's installed into the house, or that a certificate needs to be added there. And this has changed slightly in the 2021 IECC. It now says that the insulation mark needs to be provided, and you need to provide this insulation certificate, and that the insulation certificate shall be left immediately after installation by the installer in a location that is obvious to the code official so that they can look at that, so that we know what's actually been installed in that house. There are a number of materials on the market where the insulation mark is either very difficult to see or is not added to the material that's been installed. So now we're looking for an actual certificate that certifies what the density of the blow of this blown wall insulation is, or attic insulation is, so that we know that the R value of that material actually matches what they proposed to put into the building here. There's this other certificate that's defined in Chapter 4 that needs to be left at the end of the process of building a house. And there's some things that have been added to this certificate. Most pronouncedly, those things in blue here, on-site PV systems, if they're installed on the house, need to be labeled and defined on the certificate. The code ERI score, if you're using that pathway, needs to be on the certificate as well. And the code addition needs to be on the certificate. It wasn't specifically called out for in the past, and now is called out for in the code. These compliance pathways that we looked at briefly, remember that anything that is mandatory in the code is a requirement in that particular particular compliance pathway, but the word mandatory has been removed and has been replaced by the word required. These are the overarching requirements dependent on the compliance pathway. And those those mandatory or requirements now are defined in a table for sections 405 and 406, the building performance path and the energy rating index pathway there in in this new edition of the IECC. Now, that means that some of this terminology has changed slightly as well. Again, mandatory used to mean items that could not be traded off. That word mandatory now means requirements, and requirements must be met by every compliance path unless there is a specific exception written in the code. The requirements are now can be found embedded in the code language or within a table. Prescriptive requirements, those are requirements that can't be traded off in most cases and must be met when using the prescriptive compliance path and met when using other compliance path if they are included in that requirement table. Again, these are mainly requirements for how you actually install a specific component in the building. So how do you install insulation in a floor system or in an attic, for example? Now, the performance approach allows the use of trade-offs to meet a specific required R value that's been defined in the prescriptive path of the code. This gives you the ability to trade off R value in one component for greater R value somewhere else. Remember that you now have some backstops that are embedded in these performance approaches that you can't trade off below a certain R value in a specific assembly, for example. A performance approach does not override requirements of how you install an efficiency measure. So how you install that insulation in a floor system. You're given a lot of different ways to do that, but just because you trade off the R value doesn't mean you can trade off how it actually gets installed there. You can trade off the R values and U values. You can trade off air tightness and duct leakage depending on the compliance path that you ultimately choose, which performance approach you ultimately choose. So for example, again, going back to that table, this is where the table is listed. These are what used to be defined as mandatory requirements. These are the requirements for this particular section as defined in this table that's now part of 405, the building performance trade-off pathway. So when we have ceilings and R values here, it says in the prescriptive section that an R38 can replace an R49, or an R49 can replace an R60 if the full height of uncompressed insulation extends over the wall top plate. So if I'm going to go down to an R38, for example, I have to have enough room over that top plate to receive the full height of that R38 insulation, which probably means that you're going to need a raised hill truss in that assembly here. So these code changes can also impact other actually building components of that house in order to achieve the energy requirement in that house. In this case, raised hill trusses. Attic eave baffles have changed a little bit. The baffle shall be installed, which is the same. It shall maintain an opening, which is the same. And it shall extend over the top plate of the attic insulation so that you're able to actually insulate over that top plate as well. The baffle shall be installed to the outer edge of the exterior wall top plate, and the baffle shall be installed continuously to prevent ventilation air in the eave soffit from bypassing that baffle. So this is a significant change in how things installed. So the picture at the top here, we can't install like that because the baffle is not being used to fully deflect the ventilation air up and over the insulation. That fiberglass bat that's been installed down there does not stop the movement of air. So we need something that stops the movement of air, can direct the air up and over the baffle to potentially a ridge vent or a pot vent above. The other picture to the right here is demonstrating that we don't have the right amount of R value coverage over that top plate here. And then the last thing is that if we have a baffle and soffit vent that's not continuous, we also need that continuous baffle because the air in that spot eave vent might bypass the baffle otherwise there. So look at this section because it changed a bit there. Attic hatch doors changed as well. We not only have to weather strip that attic hatch and access mechanism, but we need to create an attic dam for insulation to keep that insulation from falling in at the attic hatch, but also from attics that are raised or lowered, so that you keep the insulation at the higher portion of the attic from falling off that portion onto the lower portion of the attic. And then the other thing that's added here is insulation underneath attic platforms that might be installed. You have to have a means to achieve the right level of R value below that insulation here. The floor section has been changed a bit here to be a little bit easier to understand. Here you can choose from one of these three choices of how you install insulation in that floor system. It used to be embedded in an exception. Now it's been detailed out to be easier to understand in this section of the IECC here. Basement walls have been changed a little bit. We now define conditioned and unconditioned space with regards to basements and how the insulation is installed if it's a conditioned basement here. The basement wall installation, we need to insulate from the top of the basement wall down 10 feet. That's stayed the same, but look at this section of code language because of this definition of conditioned and unconditioned basements in that section of the code here. Slab on grade insulation is another section that's had some changes. It shall extend downward from the top of the slab on the outside or the inside of the foundation, depending on your climate zone, either 2 feet or 4 feet down. It needs to be protected, and it can be cut at a 45-degree angle here. So some of these things are similar to what they were in the past, but parts of this language has changed as well here. So this is a section to look at. Sunrooms and heated garages. These sunrooms enclosing conditioned spaces and heated garages shall meet the insulation requirements of this code. So you can't just insulate a garage. If you're going to insulate the garage, you need to insulate it to the requirements of the code as well, because it's going to be considered, well, it might not be considered conditioned space from an energy analysis perspective, but you have to use those R values now as required by the code. This is a table that is used to, it's in essence a mandatory table for all the compliance paths. It's a requirement of all the different compliance paths. And if you follow this table in the code, you will be able to easily meet the air leakage requirements that are required in the code, at least for a single family code. There might be some issues with multifamily or attached housing. The name of this table has been changed to air barrier, air sealing, and insulation installation. And then specifically, these sections within this table have had some changes made to them. So you should look at the rim joists and basement and shaft penetration areas here, narrow cavities, garage, recessed lightings, plumbing, footnote B. All these different sections have changed in this table here. So the better you understand this table, the better your ability is to achieve the air tightness that's required by this code, which has also changed slightly here. The blower door testing has changed. It's become a little bit more confusing, but what they're asking for is that you have to do a blower door test, an air leakage test on the house. The maximum air leakage is not to exceed 5 air changes or 0.28 CFM per square foot of enclosure area. So the first thing you'll see is that a second metric for compliance has been added. This is a better way of measuring air leakage than air changes per hour there. But you'll also see that when you trade off, this is creating a backstop in essence for those trade-off methods where you can't trade off a leakier home than 5 air changes. That's really not how trade-offs have been working in the past, but in essence, it's creating a higher level baseline that you can't be leakier than there. So again, this is intended specifically for section R405 and 406. That would say if I put in a ton of insulation in my attic, let's say an R100 in my attic, potentially I could trade off to a leakier house than 3 air changes in climate zone 5, for example. This is saying I can't trade off leakier than 5 air changes. There is an exception that's been created in this section of code for attached housing and small houses that says that you can now use 0.30 CFM per square foot of dwelling enclosure area. Dwelling enclosure area is now defined in the code in the definitions section. And this says that instead of reaching 3 air changes in climate zone 5, for example, I could reach 0.30 air changes per 0.30 CFM per square foot of dwelling enclosure area for attached housing and units that are smaller than 1,500 square feet, I'm sorry, or smaller here. And then the last thing that is called out is that air leakage rate per climate zone here that has been in the code for a while now. Oh, energy code compliance changes in the 2021 are included in the electrical and communication outlet boxes. Basically, you need to have an airtight electrical outlet box that's sealed to limit leakage between conditioned and unconditioned space. Duct location and ducts located in conditioned space has changed as well. The duct diameter has changed slightly here, but duct location has changed more here. Basically, it's saying that ducts can be considered inside conditioned space in the way that they have in the past. If you have a tight duct system and you mount insulation over that duct, then you can call it inside the conditioned space. But now ducts that are located in floor systems, if they're installed in a specific way, can be considered inside conditioned space. That means that when you install ducts in floor systems like this, it doesn't work. But if you install a duct and you completely encapsulate that duct with insulation and you put at least an R19 between the duct and the unconditioned space to the outside, it can be considered in conditioned space here. Also, ducts that are located on an exterior wall, if they're installed with a continuous air barrier and a minimum of R10 to the outside, they can be considered inside the conditioned space here. We're running out of time, so I'm going to skip the buried insulation part here. But if you insulate your ducts well, you can demonstrate that they are inside the conditioned space of the house. The air sealing requirements for ducts is changed slightly because the testing requirements for duct leakage has changed as well. Ducts shall be pressure tested regardless of location. That used to be only if ducts were outside the building envelope, they needed to be tested. Now, regardless of where they're located, they need to be tested. They need to meet a specific testing criteria or duct leakage rate that is defined in the code now. And mechanical ventilation. If buildings and dwelling units comply with this section, they shall be provided with mechanical ventilation in accordance with the mechanical code here. And so that's still a requirement as well. However, outdoor intakes and exhausts shall have automatic and gravity openings. And now in climate zone 7 and 8, you have to use balanced ventilation in those climate zones. That's a new requirement here. Mechanical ventilation has to have a specific fan efficacy. They have to be efficient there. And you can now use either this table or this formula to determine the ventilation rate that is used in the code. Again, we don't have enough time to go through that in enough credit here. or in enough time here. But the ventilation rate is now giving you the ability to take a ventilation credit. This is the ventilation rate must be reduced by 30% if it's running intermittently here. So you need to look at this section when you're determining your ventilation rate so that you can get the correct ventilation rate that the code is actually requiring here. Mechanical ventilation systems shall be tested and verified to provide the minimum ventilation flow rates that are required by this section of code. So in the past, we haven't had to test bath fans and kitchen hoods and whole house mechanical ventilation systems to verify that they're actually meeting the flow rate that's required. Now we actually do need to test those, and you have to provide a written report that they work. The only exception is if the kitchen range hood is ducted with a 6-inch duct and only has one 90-degree elbow, then you don't need to test those ducts, that ventilation system here. Other changes in the IECC is lighting requirements. This is now a requirement that all lighting be efficient lighting instead of a percentage of the lighting. It includes now interior controls that are required on the residential side, and also some requirements for exterior lighting as well. So that is so much, and I'm sorry we rushed through that a little bit because of our time crunch, but I wanted to give you an idea of all the changes that happened in the 2021 IECC. And to conclude here, I'll go back to one of the intent statements of the code. The intent statement says that we need to learn the rules so that we know how to break them properly. That's really how we utilize the trade-off compliance pathways. We have to embed ourselves in these changes, read these changes in the code, and understand why they've been changed so that we can implement this code properly. We can break the rules. We can see the flexibility that's built into the code if we spend some time with this new language and understand what they mean. Remember that there's some upcoming trainings here in the near future. And if you have any questions, you can either stay on with us for a little bit and we can answer some questions, or don't hesitate to reach out directly to me. And I'm happy to answer any questions that you might have from this presentation. So we will now spend some time answering questions. If you can't stay on, that's totally understandable, but don't hesitate to reach out. Erica, back to you.
Thanks, Rob. It was a lot of information in a short amount of time. There will be the recording posted if anyone wants to reference it. And then also I wanted to highlight that I'm working on creating a significant changes document from 2018 to 2021 for residential and commercial. And that'll be posted in our code adoption toolkit. So please take some time to look at that, and I'll probably be sending out an email update once we have the code adoption toolkit fully posted. So we do have some questions for you, Robbie. I'm going to go ahead. We've got a couple questions on the ERI backstop. Ben, I'm going to go ahead and unmute you if you're still with us to ask Robbie your question directly.
Sure, thank you. Hi, Robbie.
Hi, Ben.
I had a question earlier about the ERI path with the renewables backstop. And in 2021, you said there's a 5% backstop for the ERI path. And I was just wondering if you could tell me what that was like in the 2018 code.
Yeah, in the 2018, the backstop was kind of twofold. There was an insulation backstop that said if you had renewables, you had to use the 2015, I believe, IECC insulation levels. If you didn't have renewables on the house, you had to use the 2009 insulation levels in the house. So that was kind of a mandatory R value backstop for the insulation levels in the house. And then if you used PV on the house, I believe it could not be used to adjust the mandatory ERI score that was required for the 2018. In climate zone 5, I believe that was a 62. Now in the 2021, you can use 5% of that energy generated through PV panels, for example, toward that ERI score.
Okay, thank you.
Yeah.
Great. Thanks, Ben. We do, I think that's mainly the question for today, Robbie. We do have a question about potentially rescheduling part 2. So I'll touch base with you on that. It looks like the ResNet conference is happening right at the same time, but worst case, the recording will be available to you as well. So with that, I'll go ahead and end the webinar today. Thank you again to Robbie for your presentation and to all the attendees. And we hope to see you next week.
Great. Thank you, everyone.